Hello, these are the exercises for section 5.7, the difference between two proportions. A study on sleep deprivation by the Center of Disease Control and Prevention reported that in a random sample of 11,545 Californian residents, 924 stated that they had insufficient rest or sleep during the preceding 30 days. In a random sample of 4,691 Oregon residents, 413 reported insufficient sleep or rest. Is there a difference between the proportion of Californians and Oregonians who are sleep deprived? Use a significance level of 0.1. So the first thing that we have to do, since this is a hypothesis test, is write our hypotheses. So the first thing, we have our null, and we have our alternative hypothesis. So here we're looking at the proportions. So our parameter is going to be a p, the p symbol. But we have two different proportions that we're looking into here. We're looking at the proportions of Californians and the proportion of Oregonians. So remember, the null hypothesis is a statement of no change. There's no difference between them. So we're saying that the proportion of Californian residents that are sleep deprived is the exact same as the proportion of Oregon residents that are sleep deprived. And that is saying that there is no difference between my two proportions. That is what my null hypothesis is going to be stating, okay? The alternative is a statement about the claim that you want to find evidence to support. So the question here is that is there a difference between the proportion of Californians and Oregonians who are sleep deprived? So we don't care if one's more or less. All I care is that they're different. So the proportion of Californians is different, is not equal to the proportion of Oregonians. Okay, so this is what we typically mean when we ask you to find and write the hypotheses. However, there are different ways that you can do it. We use the subscripts of California and Oregon because we want to make sure we referred what we meant to. But like on Geogebra, they don't care if it's Californian or Oregon, and they just have subscripts of P1 and P2. So therefore, if you did it like that, that would be fine, but it'd be really indicative that you should reference what population 1 is referring to and what population 2 is referring to, okay? Similarly, on Geogebra, or in other ways that you can write it, this P1 equals P2, that's just an equation. So you could subtract P2 on both sides, and you get this equation. So what this is saying is that this proportion of Californians who are sleep deprived minus the proportion of those Oregonians who are sleep deprived, that difference is 0. This is another way of saying that these two proportions are exactly the same. And so those are ways that you can see these hypotheses, but like I said, typically we mean this way, okay? So now that we have our hypotheses, we've got to think about what we're actually looking at, right? So we have a sample proportion of Californians where we have 924 over 11,545. And this is about 0.080. Our sample proportion of Oregonians who are sleep deprived is 413 over 4,691, which is about 0.088. So what we're looking at with the hypothesis test is we're like, okay, so we have the sample data, and the sample proportions, they're different. But we know that samples, sometimes they're different because of sample variation, or sometimes they're different because they actually are different in the population, right? So we have our sample information, and that's going to be our evidence to see whether or not we should or should not believe the claim, okay? However, we don't really care about the sample, we care about the population. So that's why we have to have the parameters in our hypotheses as P, not the sample statistic of P hat, okay? So we're going to use this evidence, and we're going to actually use them in GeoGebra, so you won't actually see this, but that's just kind of like, I want you to think about what the theory is behind it, okay? So before we go through and actually do the hypothesis test, it is good practice to check that these conditions are satisfied. So we have to have the first condition, that we have random samples or randomized experiments. So here we have a random sample of Californian residents, and we have a random sample of Oregon residents. So that's satisfied. Okay. Here, these are going to say that, do we have a large enough sample so that we can represent the population? Okay. And so we have n sub 1 and p hat. So right here we have p hat. It's not p hat California or p hat Oregon, it's just p hat. So remember p hat here, this is my pooled proportion. Okay, and this p hat is the number of people who were sleep deprived in the whole study. So those in California that were sleep deprived and those in Oregon who were sleep deprived, over all the people in the study. So all those Californian residents and all of the Oregon residents. And if you go through and you do that, you get 0.082. So my N1, remember my sample 1 was my Californian sample. So I'm going to have 11,545. And I'm going to multiply that by a p hat, which is my pool proportion of 0.082, and that equals 946.7, and that's greater than or equal to 10, so that's satisfied. Okay, then I have to go through and do N1. Again, N1 is my sample size of my Californians, which is 11,545. Times 1 minus my pooled proportion of 0.082. And when you do that computation, you get 10,598.3, and that's greater than or equal to 10, so that's satisfied. My N2 is my sample size in my second group, so it's my number of Oregon residents that I talked with. So it's going to be 4,691 times my p hat, which is my pool proportion of 0.082, and that is 354.7, which is greater than or equal to 10. And then we have to do this last condition, and we have 4,691, because again, that is my sample size of my Oregon residents, times 1 minus 0.082, and that equals 4,306 3/10. And that is greater than or equal to 10. So that means that this first criteria and the second criteria are completely satisfied. Okay, then we have to talk about whether they are independent samples. So, did the people who I chose to be in the Californian group, did they influence who I chose in my Oregon group? I didn't. So there is no match or influence between the two groups. Okay, so criteria 3 is satisfied. Okay, then we have this last criteria, and this is going to be at this, there's independence within the samples. Okay, so again, we have little n1 and capital N1. So remember, little n's, that is my sample sizes, and my big N's are my population sizes. So here, we want to know that my sample size of Californians is less than 5% of my population size of Californian residents. Okay, and here I want to say that my sample size of Oregon residents is less than 5% of my population of Oregon residents. So just as a little note, the number of Californians in 2020 is about 39 million. Okay, and the number of Oregonians in 2020 is about 4 million. Okay, so let's go through and think about what's going on here. So here, my sample size of my Californians was 11,545. And I wanted to know if that was less than or equal to my population of Californians. Divide by 0.05 on both sides. And I get that and I get that 230,900 is less than or equal to the population size of California, or the residents of Californian residents. So if all of Californians are at 39 million, then that's going to be greater than about 231,000. So that one is satisfied. Okay. Similar with Oregon, we have 4,691, less than 0.05 of the population of Oregon residents. Divide by 0.05 on both sides. And we get that 93,820 is less than or equal to the population size of Oregon residents. So remember that there's about 4 million people who live in Oregon, and so therefore this is going to be less and therefore be satisfied. So my criteria number 4 is also satisfied. Now let's go through and do our test in Geogebra. So I'm going to kind of like make a little reference here, so we know what we're going to be doing. So we're going to have in Geogebra, we have to come here and we have to deal with proportions, and we're going to have a hypothesis test. So we're going to have a test of proportions. However, we have 1 or 2 proportions that we're looking at. We're looking at 2 proportions. We're going to have a z-test, difference of proportions. You can see here that they have P1 minus P2 equals 0 as your null hypothesis. And like I said over here at the very beginning, this is a way to say that there's no difference between the 2 proportions. And that's what we assume to be true in the null hypothesis. And so that's going to be the default. That will always be 0. You actually can't change this. Okay. Then on our alternative hypothesis, we have a does not equal sign. So on our GeoGebra, we indicate a does not equal sign. So here we have sample 1 and sample 2 successes, and we have to fill in. Okay. So we are going to have to go through and fill this in for our own reference. So we have sample 1, and this is my Californians. Okay. And we have sample 2, and this is my Oregonians. Okay. We have the successes and we have n. So when you go through and are using this, we're talking about the sample successes, sample n. So even though in our book we use capital N for population, this n is referring to the sample n. So this is actually like a little n. So the number of successes in our California is those who were sleep deprived, those who had the characteristic that we were looking for. There's 924. Over our sample size was 11,545. And you can kind of look over here at the very beginning of the class, at the video, I made this P hat California. And I said these are going to be our evidences. This is going to be our evidence that to give enough evidence or not enough evidence that there actually was a difference between these 2 proportions. Okay, so you can see that this is what we always have to put into our GeoGebra, because those are going to be what kind of evidence we have. Okay, similar for sample 2, the Oregon, we had 413 that were sleep deprived out of 4,691. Okay, so we go through, we type those into our successes: 924, 11,545, 413, 4,691, and once you type those in, you get this output right here. Okay, so you can see that the sample 1 and sample 2 gets repeated down here as our successes on our N, as we fill up here. Then we're going to care about our Z, that's our test statistic, and our P, that is our p-value. Okay, so my test statistic is a negative 1.6821. And my p-value is 0.0925. Okay, so now that we have that information, we're going to make a conclusion about if we have enough evidence or not. So the first thing we want to look at is compare our p-value to our alpha. Our p-value again was 0.0925. My alpha is my significance level, and my significance level up here was 0.1. Okay, so you can see that my p-value is less than my alpha, and therefore we are going to reject our null hypothesis. Okay, which means that we have sufficient evidence to conclude that HA was true. So HA being true, remember HA being true, that these proportions of those who are sleep deprived in California is different than the proportions that are sleep deprived in Oregon. So we have sufficient evidence to believe that that is a new true standard. So we have to conclude that there is a difference between the proportion of Californians and Oregonians who are sleep deprived. Thank you.